Hi students, in today's session we are going to discuss a new model, that is the shell model, for describing the nuclear structure and the nuclear properties. Before we begin with that, we discuss the merits and demerits of the liquid drop model that we learned in the last class. The merits of the liquid drop model is that the calculation of atomic mass and binding energy can be done effectively or with accuracy using this model. And its demerit is that it cannot account for the high stability of nuclei with certain fixed numbers called magic numbers, and it cannot explain the measured spin and magnetic moment of the nuclei. അപ്പോൾ ഇന്നത്തെ ക്ലാസ്സിൽ നമ്മളൊരു പുതിയ മോഡൽ പഠിക്കാൻ പോവുകയാണ്, ന്യൂക്ലിയർ മോഡൽ, ദാറ്റ് ഈസ് ദി ഷെൽ മോഡൽ. അപ്പോൾ അതിനു മുന്നേ വാട്ട് ആർ ദി മെറിറ്റ്സ് ഓഫ് the liquid drop model? That is, it is using the liquid drop model you can calculate the atomic mass and binding energy, whereas it cannot account for the high stability of the nuclei with magic numbers. Magic number എന്ന പ്രത്യേക നമ്പറോട് കൂടിയ പ്രത്യേക നമ്പേഴ്സ് ആറ്റമിക് നമ്പറും മാസ് നമ്പറുമായി വരുന്ന ന്യൂക്ലിയൈകളുടെ ഒരു സ്പെഷ്യൽ പ്രോപ്പർട്ടി അക്കൗണ്ട് ചെയ്യാൻ ഈ മോഡലിന് സാധിച്ചില്ല, ലിക്വിഡ് ഡ്രോപ്പ് മോഡലിന് സാധിച്ചില്ല. പിന്നെ ന്യൂക്ലിയൈകളുടെ മെഷേർഡ് സ്പിൻ ആൻഡ് മാഗ്നറ്റിക് മൊമെന്റ് എന്തുകൊണ്ടാണ് അതിങ്ങനെ കാണപ്പെടുന്നത് എന്ന് അക്കൗണ്ട് ചെയ്യാനും ലിക്വിഡ് ഡ്രോപ്പ് മോഡലിന് സാധിച്ചില്ല. So much improved version or a varied version of the nuclear model was put forward, that is the shell model. In the shell model of the nucleus, the energy levels of the nucleons in the nucleus is similar to that of the electron shells in an atom. Just like how the electrons are arranged in energy levels, it is assumed that inside the nucleus, the nucleons are also arranged in energy levels. That is, the protons and neutrons are grouped in shells in the nucleus, in separate shells inside the nucleus, just like the electrons are in the various shells outside the nucleus. The protons and neutrons move in separate system of orbits around a common center. Now, the shells are regarded to be filled if they have some specific or particular number of protons and neutrons, or both. Now, the number of nucleons in each shell is limited by Pauli's exclusion principle. Here, each nucleon is assumed to be independent of all other nucleons, and each nucleon is acted upon by the average nuclear field produced by all the nucleons. ഇവിടെ ഓരോ ന്യൂക്ലിയോണും മറ്റു ന്യൂക്ലിയോണിൽ നിന്ന് ഇൻഡിപെൻഡൻ്റ് ആയി കണക്കാക്കപ്പെടുന്നു. പിന്നെ ഒരു ന്യൂക്ലിയോണിൻ്റെ മുകളിൽ ആക്ട് ചെയ്യുന്നത് അവിടെ ബാക്കിയുള്ള എല്ലാ ന്യൂക്ലിയോൺസ് അതൊഴികെ ബാക്കി എല്ലാ ന്യൂക്ലിയോൺസും കാരണമുള്ള ആവറേജ് ന്യൂക്ലിയർ ഫീൽഡാണ്. So this model is also called an independent particle model because each nucleon is assumed to be independent of the other nucleons, and each nucleon is acted upon by the average nuclear field produced by all the nucleons. Now, the nuclear behavior is determined by the excess or deficiency of nucleons with respect to the magic numbers. So, these are the features of the shell model. So, as per the shell model, the nucleons in the nucleus are arranged in energy levels just like the electron shells in an atom. The protons and neutrons are grouped in separate shells, and they move in their own system of orbits around a common center. The shells are regarded to be completely filled when they reach a specific number. These numbers are called the magic numbers, and the number of nucleons in each shell is limited by Pauli's exclusion principle. Since each nucleon is assumed to be independent of the other nucleons and each nucleon is acted upon by an average nuclear field, it's called the independent particle model. Now, the excess or deficiency of nucleons with respect to the magic numbers is responsible for the nuclear behavior. Now, let us go into some of the evidences of the shell model. that is evidences which prove that this shell model a is a correct model, uh, which is comparable to our actual nucleus. So nuclei with magic numbers of nucleons are found to exhibit unusual stability. Now this was one of the postulates of the cell model, and it is external, or it is experimentally proved or evident too. That is, the nuclei with magic number of nucleons are found to exhibit unusual stability. Then isotopes of elements having abundance greater than 60% also belong to the magic number category. That is SN50. That is 1050 has 10 stable isotopes. So 50 is a magic number here. Now calcium 2040 has six stable isotopes. 20 and 40 are magic numbers. So Z equal to 20, 50, etc. show more stability. 20 is a magic number. Now, 20 is in the case of calcium, 20 is a magic number, and 20 represents the number of protons, and 40 minus 20 equal to 20 represents the number of neutrons. So, the number of neutrons and the number of protons in calcium are magic numbers. So, calcium has six stable isotopes, because all these isotopes are stable because calcium has a magic number of protons and neutrons. Now, there are three main radioactive series that decay into lead 82 to 08 with Z equal to 82, that is number of protons 82 and number of neutrons 126. Both these numbers belong to the magic number category. So lead 82 to 08 is a very stable isotope. Then nuclei with n equal to magic numbers cannot contain further neutrons as the shells are already closed. Nuclei with magic number of n and z are found to have zero quadruple moment, and hence are spherical, while the other nuclei are distorted in shape. So, what is meant by quadruple moment? Quadruple moment is uh, shows us, or nuclear electric quadruple moment are a measure of how much nuclear charge distribution, or a measure of how much the nuclear charge distributions depart from sphericity. Sphericity means spherical shape. So, how much departure does the nuclear charge distribution show from a spherical shape? Is represented by quadruple moment. Now, zero quadruple moment means your nuclei is spherical. Okay, and a non-zero quadruple moment represents a distortion in the spherical shape. So nuclei with magic number of capital N, that is number of neutrons and protons, are found to have zero quadruple moment, or such nuclei are spherical. Thus, the nuclear behavior is determined by the excess or deficiency of nucleons with respect to the closed shell of nucleons corresponding to magic numbers. Now, the shell model is able to account for several nuclear phenomenon in addition to magic numbers. It is observed that even nuclei are more stable than odd nuclei. I have already told you that majority of the stable nuclei are even, and there are just five stable odd nuclei present. So this is obvious from the shell model. That is, in even nuclei, uh, only completed subshells are present, which accounts for its greater stability. Then the shell model is also able to predict the total angular moment of the nuclei. In even nuclei, all protons and neutrons should pair off to give zero angular momentum, whereas in even odd and odd even nuclei, the half integral spin of the single extra electron should be combined with the integral angular momentum of the rest of the nucleus to give a half integral total angular momentum. That is, the odd അതായത് ഈവൺ ഓഡ് അല്ലെങ്കിൽ ഓഡ് ഈവൺ ന്യൂക്ലിയയിൽ എല്ലാ the spin due to all the pairs of neutrons and protons will give you an integral angular momentum, whereas there will be a single extra nucleon, which makes it an even odd or odd even nuclei, and that single extra nucleon will have a half integral angular momentum, which when added to the integral angular momentum will again give you a half integral total angular momentum. So I think that is clear to you. An ordered nuclei will have an extra neutron and an extra proton. So the half integral spin should yield an integral total angular momentum. Okay. So both these predictions are these predictions can be made using the shell model, and both these predictions have been found to be uh, experimentally correct, and they have been confirmed experimentally. What were the two predictions? One is that even nuclei is more stable than odd nuclei, and predictions regarding the total angular moment of the nuclei, that is in even nuclei the angular momenta pair off to give zero angular momenta, and in even odd and odd even nuclei the total angular momentum is half integral, and in ordered nuclei the extra neutron and extra proton will whose each of which have half integral spin should yield an integral total angular momentum. So the shell model could predict about the stability of even nuclei, and it could give an insight into the total angular momentum of the nuclei. So the shell model could overcome some of the demerits or inadequacies of the liquid drop model. So I hope this session on shell model is clear to all of you. If you have any doubts, please do contact. Thank you.